Hello, this is mathjazz from Almost Cool, and we are picking up where we left off in variant limits. And right now we have to hit this target 1 up here, so can we hit that? Yes. Can't hit it on any of these nice units here, so we're going to have to swap out to this. We want it to equal 1. Where can we do that? Oh, right here. Okay, so we have now set the transporter to go up to the top of this room. We can place a battery here, go through this gate.
Excellent work.
Okay, so what's in here that we need? Is this where I have to continue if I'm going to continue going on? Okay. So we left a battery in the room below us. We might have to go back and get. So, oh, what's this? Okay, so we're gonna go back and get that battery before we go any further. So we have to reset the portal to... Let's see, we want it to hit 2, and 2 is here. Okay, so coming over to this corner of the building and seeing this teleport orb leads me to believe that I do not need to worry about collecting this battery again. It looks like I'll be able to swing around and get it on the return. So I'm going to keep going down through here. Yeah, this is in the right spot that we'd need to be to hit a teleport pad up there. Okay, and we have to hit 4, so let's do looks like 4 times 1. Or -4 times -1. Okay, so now we teleport, we grab our last battery. I want to pick up the... Can I not pick up a second battery? I think I might not be able to pick up a second battery. Was there a third battery in here? I didn't see any place to pick up a battery in here. In fact, I don't really know why I came down here. Oh, we can hit that target 3 down there. Let's see. What equals 3? So, -3 times -1 equals 3. Okay, so let's teleport down there. We'll probably need our battery, and then we'll go back for the other battery. Yep. Because apparently we can only carry 1 battery at a time. Okay. Oh yeah. Okay, so we need to hit 3 again, which means we need to be here. Wait. put a battery in there? Do I need 2 batteries in here? Oh. That's unfortunate.
The solar vault! There will definitely be an industrial battery inside that we can use to power the cargo transporter.
To open the solar vault, determine when this function achieves the value marked by the horizontal line.
Go in here. Ah. Choose the obscured interval where the continuous function attains the value in orange per the intermediate value theorem. That one. And then this one. Okay, so let's first talk about what the intermediate value theorem is. The intermediate value theorem is intuitively, it means that if you're not allowed to teleport, then you must cross every point between A and B as you're walking between A and B. Stated mathematically, it's if a function is continuous on a closed interval from A to B, and the function's value at A is less than the function's value... Well, let me rephrase that. Then I won't have to state it 2 different ways. So, if f is continuous on a closed interval A to B, and y is between f of A and f of B, then there is a point C between A and B such that f of C equals y. So, if we're assuming that this white function is continuous, if we see that the function is above our value y is the orange line here. So f is continuous, and we're just not able to see these sections of the graph here. If y is between f of A and f of B, then somewhere between A and B, f crosses y. So notice that here, f of A and f of B are both less than y. Here, f of A and f of B are both greater than y. But here, f of A is greater than y, which is greater than f of B. So somehow, and we don't really know exactly where this happens, this function, if it's continuous, must cross the line. Now, if we assume that this is like some nice polynomial function, it probably crosses it about there, I think. You know, if it has this nice smooth curve. But we don't know that this is a polynomial function. We don't know anything about this function except that they told us it's continuous. So for all we know, this function here has a nice sharp corner here, goes all the way up to here, goes all the way back down to here, and then comes up to here and has a sharp corner there. It might, because all we were told is this is continuous, not that it's smooth, not that it's polynomial, not anything else. So we don't know anything about what goes on between here and here other than because it's continuous, it must have crossed this orange y value at some point between this side and this side. So we're going to click that. And it goes the same for all of these. So here is where the intermediate value theorem says that we must have a y value, and we must have one here as well, and here as well.
That's the first battery. Well done. We need 2 more.
Ooh, it even leaves it lit up for you. Notice how the things that I selected are still there. Okay, so that was one place to go. Here's another place to go. Now, are these industrial batteries different from batteries I'm holding? They probably are, otherwise they wouldn't have made such a big deal about it. I didn't like leaving my batteries there. It was sad. Oh, is this what an industrial battery looks like? Is that what I put there? I think so. Okay, so this is the one that we went through. And now this is a new door to go through. Looks like they open one at a time for us. I think it's weird that the ocean is purple, but all of the streams are blue. Like, it... I think it kind of makes sense, because, like, the ocean is kind of greenish. It's like a blue-green, if you go look at the beach in California. But the... Well, I guess the water in the rivers is also kind of a blue-green. Maybe it's the sunset. That could be it. Anyway, it's pretty. Like it. Okay, so let's try going to 2 first. So we need f plus g to equal 2. Let's see. Maybe we can go to 3 first. If 2 plus 1.5 is too big. Yep, it looks like we'll have to patch this immediately. So, let's see. We have this, G is continuous, F is continuous from the right, so we know that we have to have something that is continuous from the right. Continuous plus continuous equals continuous, by the way. So, continuous from the right plus continuous from the right equals continuous from the right. So since G is purely continuous, we know that since G is purely continuous and F is continuous from the right, G is continuous from the right. And continuous from the right plus continuous from the right means continuous from the right. So we get continuity from the right. And since this value for F is bigger than the limit from the left, we also know that the F times G is going to be... Oh, it's times, not plus. Okay, well, it's the same thing. F times G, so continuous times continuous is continuous. So we know that we're going to be continuous from the right. However, I think that because these are larger negative numbers, when you multiply them together, the negatives will cancel and we'll get a larger number overall. So this will be the limit from the left, and we'll have the value and the limit from the right being equal to each other and smaller, because we're going to be multiplying like -1/2 times -2 versus multiplying -1.5 times -2. -1.5 times -2 is going to be a bigger number. So this looks like the answer for the first one. Second one, we have continuous and continuous, so we need one orb and it's going to be continuous. Here we have so the limit from the right and the limit from the left equal each other for F and for G. So we're going to need, well, but the values are different. So the limits will be equal, but the values will be different. And the product is 0 here, but the product of the values is -1 times -2 is +2. So the value is going to be bigger than the right and left limits, but the right and left limits will be equal to each other. There's a special name for this. When you have the situation that the value is different from the right and left limits, but that the right and left limits are equal to each other, it's called a removable discontinuity. This means that you could remove the discontinuity by moving a single point. Okay? If you have to move more than one point to fix a discontinuity, it's not called removable. But if you can move one point up or down until it lines up with the right and left limits and equals the right and left limits, it's called a removable discontinuity. That's what's happening here. Okay, so we have continuous and continuous, so this will be continuous as well. And here we have continuous and continuous from the left, but the limit from the right is not equal to the value or the limit from the left. So we're going to need 2 orbs for this. And it looks like the limit from the left is going to be bigger than the value in the limit from the right. So this should be done now, and it should be done correctly. Yep. Oh, and it's a cute little face, too. I think that they like doing these in the levels, making these little faces with the graphs. Okay, so let's try patching. We'll take the limit from the left. Okay, So, oh, did we want to go to 3 first? Do we want to go to 1 first? I think 1 is where the battery's going to be, because if we look down there, there's this like console, and if we look at 1 and 3, they have these cranes, and we had to move the cranes last time for some reason. So I think the 3 is where the battery will be, and if I'm wrong, then oh well. But we'll go to 3 first and pick up the battery. No, no battery. Oh. Okay, let's try. Well, we know that if we just swap to values, then we'll hit 1. So we might as well go there next. Is there a battery? Yes! There's a battery. I guess the last room that we went to... Oh. I'm stuck. That was weird. Okay, so it looks like... Oh, what I was going to say was, in the last room we had to pick up a battery off of a crane too, now that I remember that properly. Let's go... Should we put it in 3? And then check what's at 2? Should we go to 2? I think we'll go to 2 next. Okay, so let's find how we get to 2. Oh, it's just the value here. Okay, so we go to 2 and we'll pick up whatever's there. Is there a battery? Oh, we can't pick up more than 1 battery. I forgot. Oh well. But at least we know where another battery is, so that's good. So we'll put this battery... No! We'll put this battery in the console down there. Okay. So, 3. Oh, wait. There we go. I think that particular transition is kind of making me seasick. Okay. Ooh. Ooh, there's a platform here.
There
Yay.
must be incredible aurora at the poles. Under different circumstances, I might appreciate the sublime beauty of what's happening.
Confirmed. Flux transfer through the magnetic tether manifests as energetic particle events, as well as geomagnetic induction currents.
If the power matrix didn't span the planet, the consequences would be less severe. As it is, the magnetic storms discharge everywhere. There is no escaping it.
That should hit 4. Like, that should easily hit 4. My output 2 plus 2 is 4. And it's not hitting it. Okay, let's patch it. This one is continuous here. The next one is also continuous. And okay, so this one here. Okay, so the function is not defined at all between like this x value and this one, so we'll leave that as doesn't exist. So those ones don't exist, but this one is continuous. f times g. That's, is it saying that it's an infinite limit? This goes up to infinity. This goes down to negative infinity. This is a negative times a negative is a positive, so the product goes to positive infinity. It's still not going to be continuous. Oh, okay. So it's it is accepting infinite limits, and what I mean by that is that the limit of the f times g is infinity. So let's see here. We have a negative g and a negative f, and the negative f goes to negative infinity. So multiplying them together gives us a positive infinity. Positive g times positive f is going to positive infinity, so that's also going to infinity. So, but there's no value. We don't allow our functions to equal infinity anywhere. There we go. Okay, so let's try the patch. That works. Okay, so I need to put another battery there eventually. There's one in the little mat that we can pick up, I think. Can we? It'll take away those platforms if we... Oops. I think that we have to get another battery somewhere else. Okay, so let's try hitting 1. There we go. And there's a battery. Okay. And go. Oops, too far. Come on, teleport.
Fantastic! You did it.
But it didn't get me to a battery.
I have to wonder. Could the Mantha have escaped upon the star arcs? Is it even a plausible hypothesis, Preceptor?
Fuel to mass ratios indicate the entire Mantha population could not have escaped upon the interstellar transport vessels based upon their specifications.
Then where did everyone go? And where are the star arcs now?
Okay, so I need to get some more batteries. And to do that, I need to go somewhere else. Well, I will solve that in the next episode, so I hope that you're enjoying this live stream, and I hope that you're enjoying learning something about calculus. So, bye!